Hello engineer, welcome back to Mikebaba-CATIA channel. Today is lesson 18, the second part of our plane lesson. More importantly, we are introducing a global professional standard, the geometrical set. If you want your models to be organized and manageable, don't miss this lesson. Ready? Let's begin.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true.
Hello everyone and welcome back to the channel. Today we continue our deep dive into the plane tool in the reference elements toolbar. Today we're unlocking the true power of planes by tackling the final most advanced methods, including the pro modeling essential geometrical set. In the last lesson, part 1, that link is in description, we reviewed the basic 7 methods. Let's jump right into the remaining crucial methods. Suppose I have a curve and 3 points on the page. The point with pink color is exactly in the middle of the curve. The point with green color is located at an imaginary point on the curve. The point with blue color is outside of the curve. I activate the plane tool. The settings window opens. I select the drawing mode, normal to curve. In this settings window, I must introduce one curve and one point to the software. In this mode, a plane is created perpendicular to the curve at the selected point. I do that. I select the curve and the green point. You see the result. I activate the tool again. First, I select the curve. This time, I don't select a point. Since I have not specified a point, you see the word default middle in the box next to point. If I click OK in this state, a plane perpendicular to the curve will be created exactly in the middle of the curve. I use the tool again. This time, after the curve, I select the point outside of it. You see a plane on this point take shape. I activate the tool again. After selecting the curve, I select one of the end of the curve when the framework next to point option is active. Now the plane preview moves to that point on the curve. The plane is created perpendicular to the curve at this point. There is another option in the settings window called Ratio of Curve Length. If I activate this option, the ratio box below it becomes active. Here I can type a number from 0 to 1. If I enter 0 in this box, the plane will be created where it is now. If I give the number 1, the plane will be created at the opposite end of the curve. If I enter 0.5, the plane is created exactly in the middle of the curve. I enter the number 0.3 in the box. I click the preview button. You see that the created plane moved closer to one side. The reverse direction button also makes a change. It changes the direction of distance measurement from one side to the other. I click the reverse direction button. You see that the plane moved and became closer to the opposite side. I click OK. The plane is created. Tangent to surface. I activate the plane tool again. I set the drawing mode to tangent to surface. This mode is similar to creating a plane tangent to a curve. The difference is that in this mode I must introduce a curved surface and a point. I select the cylindrical surface. Then I select a point on that surface. You see that the preview plane appears tangent to the surface at the selected point. Equation. I set the drawing mode to equation. As you know, the algebraic equation of a plane is ax plus by plus cz equal d. We can draw a plane by giving values to parameters a, b, and c. When this option is active, the shape of the settings window changes as you see. In the first three boxes, we enter the values for the coefficients of x, y, and z. These numbers determine the orientation of our plane in a space. For example, if we only set c equal to 1, our plane will be exactly perpendicular to the z-axis. In the fourth box, we enter the constant value d. This value defines the distance of the plane from the coordinate origin in the direction of the normal vector. In the fifth box, labeled point, we define the central point. This point is the coordinate origin by default, but we can also select any other point to define the reference for the equation. Okay, the discussion about the plane equation is enough here. Mean through points. I activate the plane tool again. I select the mean through point mode. The settings window changes according to the selected mode. You see that there is only one option below it called points. I must introduce at least 3 points to the software. By selecting the points, a plane is created. This plane passes through the average distance of the selected points. This method is used when our points are not located on a single plane and we need a best fit plane. Now I draw 4 points. I hide my main planes. For this, first I click on XY plane. I hold the Shift key, then I click on ZX plane. 3 planes will be selected. I do a right click. A menu opens. I use the hide command. I create 4 points using coordinates. The first at point 0, 0, 0. The second at point 0, 0, 100. The third at coordinates 0, 100, 0. And the fourth at coordinates 100, 0, 0. I activate the plane command. I set the drawing mode to mean through points. I select the 4 points in order. I click OK. The plane is created. If I connect the 4 points, you see that a pyramid is formed. The plane is located exactly in the middle of it. Between. I activate the plane command again. The settings window opens. I set the drawing mode to between. In the settings window, you see 2 options, element 1 and element 2. Here I must introduce 2 surfaces or planes to the software. Based on the numerical value we enter in the ratio box, the software creates a plane between the 2 selected elements. In the box next to element 1 and 2, I select 2 parallel planes. If I set the ratio value to 0.1, the plane is drawn exactly in the middle of the 2 selected surfaces. Now let's change the ratio to see its effect. If I set the ratio to 0.2, the created plane will be much closer to element 1. Conversely, if I set the ratio to 0.8, the plane will move closer to element 2. I will now set the ratio to 0.5 again and click OK. I set my view. You see that the plane is drawn exactly in the middle of the 2 selected surfaces. Note that instead of the planes, we can select 2 faces of a volume. I activate the plane tool. I activate the between mode. I select 2 non-parallel surfaces. I click OK. You see that a plane is created. Professional modeling tip: Geometrical Set. Okay, up to this point we have covered all the methods for creating a plane. But now It's time to introduce a very important professional standard in CATIA that will make your work tidy and your models manageable. This standard is the use of a geometrical set. In complex designs, all reference elements, point, line, plane, often fall under the part body. This makes the design tree messy and difficult to manage. To prevent this problem, we must place all auxiliary reference elements in a separate folder. This folder is named Geometrical Set. We can make this folder from two ways. First, when we create a new part, in the New Part window, we must select second option. This option is Create a Geometrical Set. Or if we are in part design environment, to do this, go to the Insert menu and choose Geometrical Set. We will name it Reference Geometry. From now on, before running the plane command, make sure the geometrical set is active by double-clicking on it. This ensures that new planes are created inside this set. This makes your model much more organized and professional. Okay, today's lesson is finished here. We have now fully covered all methods for creating a plane in CATIA. Please watch the lesson twice. Practice with me during the second time. Good luck. Goodbye until the next lesson.
Let's build the future. Come with me, don't hold back. Turn your thoughts into a track. Dream it, see